Hey everyone, welcome back. This is Cracking the GRE Math Subject Test. We're on the linear algebra chapter. This is the 9th problem. This problem gives you a 4x4 matrix, and one of the values is missing. Here it is, the x. And they're asking you which value of x will make this matrix non-invertible. Well, if you know what non-invertible means, then there's a few different ways to solve the problem. Because non-invertible could either mean that the determinant is 0, or it could mean that one of the rows or columns is a linear combination of the other rows or columns, or it could mean a bunch of other things, but we're going to use these two things. You can either, I'll show you two ways to do the problem. If you, here I'll write one column is a LC. LC means linear combination of the other columns. So the question is, what value of x will let us write the third column as a linear combination of the first, second, and fourth column? Well, if you kind of look at it for a second, you notice that 7 minus 6 is 1, minus 1 is 0, 5 minus 4 is 1, minus 0 is still 1, and 8 minus 7 is 1, minus 1 is also 0, and then 0 minus 0 is 0, minus 1, that gives us a negative 1. So if you take column 1, subtract column 2, subtract column 4, and then multiply the whole thing by negative 1, that'll give you 0. 5 minus 4 is 1, negative 1, and then another 0, and 1, which means that x would have to be negative 1. So the answer is A. That value of x will allow column 3 to be written as a linear combination of columns 1, 2, and 4, which means that the matrix is non-invertible. The other way to do this problem is to find the determinant and set it equal to 0. Well, if you expand, one way to find the determinant is to expand over a certain column. Well, let's use column 3 because it's got 2 zeros. We could have also used row 4. Remember, you write plus, minus, and then you can do, well, 0 times anything is 0, so that doesn't matter. So you get minus x times the determinant of, you have to cross out x's row and x's column, and then expand on the matrix that's left over. So we get 7, 6, 1, 8, 7, 1, 0, 0, 1. And the next 0 doesn't contribute, and then you get a minus 1 times the determinant of, I'll use a different color to cross out this row and this column. So now we have 7, 6, 1, 5, 4, 0, 8, 7, 1. Okay, well, what's the determinant of this first matrix? We can expand on this third row, well, 0, 0, and then 1. So 1 times the determinant of 7 times 7, 49, minus 6 times 8 is 48. That's just 1. So this will give us minus x. By the way, we want to set this whole thing equal to 0. And now we need to find the determinant of the second matrix. It gives a different color. Let's expand on the third row. Okay, so we get 1 times the determinant of 5 times 4 is 20, minus 5 times 7 is 35, minus 4 times 8 is 32. So 35 minus 32, I'm going to write this in parentheses. 35 minus 32 is 3. The 0 isn't going to contribute, and then you get plus 1 times the determinant of, let's cross that out, 7 times 4 is 28, minus 6 times 5 is 30. That's going to give us negative 2. So 3 minus 2, that's just 1. So we get that negative x minus 1 is equal to 0, or negative x is equal to 1, or x is equal to negative 1, which is the same answer that we got before.